Hi to everyone, myself Dr. Dhananjay Rao, working as Assistant Professor in the Department of Chemistry. Today I am going to teach about energy sources. In that I am going to cover solar energy. In this session I am going to cover these topics: energy sources and energy sources needed, and classification of energy sources, and solar energy. See, before going to this, you should know about energy sources. Energy resources may be defined as any property which can be converted into work. What is energy resources? The energy resources can be defined as any property which can be converted into work. That is called energy sources. Energy is defined as the capacity to work. What is energy? Energy nothing but it is the capacity to do work is called energy. What is energy resources? Energy resources may be defined as any property which can be converted into work. That is called energy sources. What is energy? Energy is defined as the capacity to do work is called energy. Energy sources need. What is the purpose of energy sources? Energy essential for human societies. Energy is essential for the human societies. Energy required for domestic as well as industrial process like mining, transport, lighting and heating. The energy required for domestic as well as industrial process like mining, transport, lighting and heating. For this purpose, energy is required. Energy consumption of India is increasing rapidly. The energy consumption of India is increasing rapidly because of growing population and rapid urbanization of country. Energy consumption of India is increasing rapidly because of growing population and rapid urbanization of country. The lifestyles of are changing from a simple way to the luxurious lifestyle. The lifestyles of citizens, Indian citizens, changing from a simple way to luxurious lifestyle. The lifestyle also changes from simple to luxurious. Okay, which further increases dependency on energy. Okay, it leads to the increase further dependence on the energy. Okay, na dependence on the energy. India is world's 60th largest consumer. Okay, in the worldwide, the India is world's 66th largest consumer. Industry, transportation and residential sector. In this industry and transportation and residential sector, the India is the world's 6th largest consumer of energy. Presently, 95% of energy is available only from the fossil fuels such as coal, oil and natural gas. Presently, 95% of energy is available only from the fossil fuels like coal, oil and natural gas. Okay, what is the purpose of energy or energy sources needed? See, energy is essential for human society. For every human society, energy is essential. Energy required for domestic as well as industrial purposes. Energy is required for domestic as well as industrial purposes like mining, transport, lighting and heating. For this purpose, energy is needed. Energy consumption of India is increasing rapidly because energy consumption of India increasing rapidly because of growing population and rapid urbanization. Because of these two, the energy consumption of India is increasing. Okay, the lifestyles also, human lifestyles also changing from simple way to luxurious lifestyles, which further increase the dependency of energy, which further increases the dependency of on energy. Okay, India is world 6th largest consumer. Okay, India is the 6th largest consumer in the industry, transportation and residential sectors. In worldwide, the India is the 6th largest consumer. Presently, 95% of energy is available only from the fossil fuels. Okay, 95% of the energy is available only from the, we are getting 95% of energy from the fuel fossil fuels like coal, oil and natural gas sources. See, classification of energy sources. Classification of energy sources. Based on continual utility, energy sources can be classified into two types. Based on continual utility, energy sources can be classified into two types. One is renewable energy resources and second one is non-renewable energy resources. The classification of energy sources based on continual utility and Energy sources, these are classified, energy sources are classified into two types. First one is renewable energy resources and second one is non-renewable energy resources. See, renewable energy resources. These resources can be generated continuously and are inexhaustible. Okay, these resources can be regenerated and continuously and are inexhaustible. These are called renewable energy resources. Example: wood, solar energy, wind energy, and hydropower energy, and tidal energy, and geothermal energy, etc. These are example for the renewable energy resources. These resources can be generated continuously and are inexhaustible. These are called renewable energy resources. Example for the renewable energy resources are wood, solar energy, wind energy, hydropower, tidal energy, and geothermal energy, etc. These are the example for the renewable energy resources. And non-renewable energy resources. Non-renewable energy resources nothing but these resources are natural. The non-renewable energy resources are, these are resources are natural that cannot be regenerated. That cannot be regenerated once they are exhausted. These that cannot be regenerated once they are exhausted. These are called non-renewable energy resources. They cannot be used again. These non-renewable energy resources cannot be used again. Only one time you can use. Example: coal, petroleum, natural gas, and nuclear fuels. These are the example for the non-renewable energy resources. See, the classification of energy resources based on continual utility and energy resources can be classified into two types. One is renewable energy resources and second one is non-renewable energy resources. What is renewable energy resources? These are resources can be regenerated continuously and are inexhaustible. These are called renewable energy resources. Example for renewable energy resources are wood, solar energy, wind energy, hydropower, and tidal energy, geothermal energy. These are the example for the renewable energy resources. The second one is non-renewable energy resources. These resources are natural that cannot be regenerated once they are exhausted. These resources are natural that cannot be regenerated once they are exhausted, called non-renewable energy resources. They cannot be used again. They cannot be used again. Example for non-renewable energy resources are coal, petroleum, natural gas, and nuclear fuels. These are the example for the non-renewable energy resources. See, non-conventional energy resources and conventional energy resources. See, non-conventional energy resources, these are renewable. Non-conventional energy sources are renewable. These are continuously available. Non-conventional energy sources are continuously available. No need to conserve. The non-conventional energy sources, no need to conserve. Pollution free. The non-conventional energy sources are pollution free. Example for non-conventional energy sources are solar energy, wind energy. These are the example for the non-conventional energy resources. What are the non-conventional energy resources? See, the sources are, these are renewable. Okay, the non-conventional energy sources are renewable and these are continuously available. Conventional energy sources are continuously available. No need to conserve. Okay, the non-conventional energy sources are no need to conserve, and these are pollution free. The non-conventional energy sources are pollution free. Example for non-conventional energy sources are solar energy, wind energy. These are the example for non-conventional energy sources. The next one is conventional energy sources. Next one is conventional energy sources. See, conventional energy sources are non-renewable. Okay, the non-conventional energy sources are non-renewable, and these conventional energy sources will be exhausted one day. Okay, after some time, after some days. Okay, these conventional energy sources will be exhausted. Okay, necessary to conserve. Okay, the conventional energy sources are necessary to be conserved. These are necessary to be conserved. Okay, cause more pollution. These conventional energy sources cause more pollution. The example for the conventional energy sources are coal and LPG. These are the example for the conventional energy sources. See, non-conventional energy sources. These are renewable. The non-conventional energy sources are renewable, and these non-conventional energy sources are continuously available, and these non-conventional energy sources need not to be conserved, and these are pollution free. Non-conventional energy sources are pollution free. Example for non-conventional energy sources are solar energy and wind energy. These are the example for the non-conventional energy sources. The conventional energy sources. Example for the what is the conventional energy sources? These are non-renewable. The conventional energy sources are non-renewable, and these will be exhausted one day. Okay, after some days, these conventional energy sources are will be exhausted. Okay, these conventional energy sources will be exhausted one day. Okay, necessary to be conserved. These conventional energy sources will be necessary to be conserved. Okay, these cause more pollution. Conventional energy sources cause more pollution. Example for the conventional energy sources are coal and LPG. These are the example for the conventional energy sources. Okay, renewable energy sources. In that we are going to discuss about solar energy. The solar energy comes under renewable energy resources. See, solar energy. Sun is the ultimate source of energy. Sun is the ultimate source of the energy. Energy is derived from the sun's radiation is called solar energy. What is solar energy? The energy is developed or derived from the sun's radiation. Okay, sun's radiation. If you develop the energy, that is called solar energy. What is solar energy? Energy is derived from that sun's radiation is called solar energy. Traditionally, solar energy is used for drying clothes and drying food grains. Traditionally, this solar energy is used for the drying clothes. Okay, for drying clothes purpose, we use the solar energy, and also for drying the food grains. For drying the food grains, we are using this solar energy. For the preservation of eatables. Okay, na? By drying, we can preserve the eatable things by using this solar energy. And obtaining salt from the seawater. From seawater, by evaporating the water from the seawater, we will get the salt. Okay, by using solar energy, these are the traditional application we have. The traditional applications are from the traditional application from the solar energies are, see, by we can dry the clothes, and we can dry the food grains, and also we can preserve the eatable things by drying and obtaining salt from the seawater. These are the traditional applications of solar energy. What is solar energy? The energy is derived from the sun's radiation is called solar energy. The energy is derived from the sun's radiation is called solar energy. The advantages of solar energy. See, what are the advantages of the solar energy? Solar energy is freely available. Okay, solar energy is freely available. We don't need to pay any cost for the solar energy. Solar energy is freely available. It does not produce ash. Okay, by on combustion, some fuel cells produce ash. Okay, the byproduct as ash. But the solar energy will not produce any ash and fumes and noise pollution. Okay, the solar energy will not produce any ash content and fumes and noise pollution from the solar energy. Hence, it is clean, noiseless, and environment friendly energy. The solar energy is free from this noise and these fumes, ash, and it is eco-friendly energy. Okay, the advantage of the solar energy are solar energy is freely available. It does not produce any ash, fumes, and noise pollution. Hence, it is clean. Okay, noiseless, and environmental friendly energy. It saves money in long run. It saves money in long run. If you use solar energy for long term, we can save the money. It is renewable form of energy. It is renewable energy form. Okay, it is a form of renewable energy. So solar energy comes under renewable energy. Okay, these are the advantages of the solar energy. See the disadvantage of the solar energy. See next the disadvantage of the solar energy. The initiation cost is very large. For solar energy, we have to insert some setup. That initiation cost is very large. The initiation setup cost is very large. Energy should be stored in batteries. We have to store this solar energy in batteries, electricity from batteries. Okay, energy should be stored in batteries. The large space is needed for installation. For installation, we need large spaces required. Okay, energy generated is depend on solar intensity. Energy generated is depend on solar intensity. In sometimes solar intensity is less. Rainy season the solar intensity is less, and in summer season solar intensity is more. So the developed energy, the energy generation is depends upon this solar intensity. These are the disadvantages of the solar energy. What are those? The installation cost is very large. Okay, the installation cost is very large. Energy should be stored in batteries, so we have to purchase batteries for to store the solar energy. The large space is needed for the installation. For the installation purpose, large space is required, and energy generated is depend on the solar intensity. The solar intensity, if solar intensity is less, energy produced will be less. If the solar intensity is more, the energy generation will be more. Now we have several techniques for harnessing solar energy. Now we have different types of solar energy initiation techniques. The photovoltaic cell is a device which converts solar radiation into electrical energy by using the semiconductor device. Different types of solar energy producing equipments are there. In that, the photovoltaic cell is one of the example. Photovoltaic cell is a device which can convert solar radiation into the electrical energy by using the semiconductor device. This photovoltaic cell is made up of with semiconductors. Okay, na? This photovoltaic cell convert the solar energy into electrical energy. See, the solar cells. The solar cell is a device that can convert the photons from the sun or solar light into the electricity. Solar cell is a device that converts the photons from the sun and it converts the solar light into the electricity. They are also known as photovoltaic cells. Those are also known as photovoltaic cells, are made up of semiconductor materials like silicon and gallium. These photovoltaic cells are made up of with semiconductors like silicon and gallium. When solar radiation fall on them, okay, when solar radiation fall on these photovoltaic cell or these semiconductor device, the potential difference is produced, which cause the flow of electrons and produce the electricity. When solar radiation fall on this photovoltaic cell, then potential difference is produced. The potential difference is produced on this photovoltaic cell and cause the flow of electrons and produce the electricity. The flow of electrons takes place and it produces the electricity. By using gallium arsenide, cadmium sulfide or boron, efficiency of the PV cells can be improved. By using the gallium arsenide and cadmium sulfide of boron and efficiency of the photovoltaic cell be improved by using these semiconductor materials. See, this is the photovoltaic cell or solar panel. If the solar radiation falls on this, the potential difference is existed, then flow of electrons takes place, then it will give the energy, solar energy. See, the photovoltaic cell are made up of semiconductors such as doped with silicon materials. The photovoltaic cells are generally made up of with semiconductors like silicon materials. Silicon comes under 4th A group. 4th A group. Silicon, carbon, silicon. Okay, these are comes under 4th A group. 4th group. Okay. When these silicon materials are doped with some materials like third group elements or fifth group elements. If the silicon is doped with third group elements like boron, aluminum, gallium, indium. Okay, if silicon is doped with third group elements like boron, aluminum, gallium, and indium, if that produce p junction diode. Okay, p junction diode or p type of semiconductor you can get. If the silicon is if silicon is doped with the fifth group elements like nitrogen, potassium, okay, nitrogen, phosphorus. Okay, by using these materials, if you dope with the silicon, we will get the n type of semiconductors. Okay, see, the boron electronic configuration is 1s2, 2s2, 2p1. 1 electron need for this, 2 electrons need here. The silicon electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p2. The phosphorus electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p3. There are two types of semiconductors materials called positive type and negative type semiconductors. When when the silicon is doped with, okay, n type of silicon is doped with third group elements like boron, aluminum, gallium, okay na, that will produce, okay, p type of semiconductor, that is positive type of semiconductor. These are the energy carriers are the holes in the p type of semiconductors. P type of semiconductors, the holes are the carriers in the p type semiconductors. If the silicon is doped with the third group elements like fifth group elements like nitrogen, phosphorus, okay, if you dope with nitrogen, phosphorus, like, it will produce n type or negative type semiconductor. In this, the energy carriers are the negative charge, okay na, the negative charge is the electrons are the energy carriers. In p type of semiconductors, the energy carriers are the holes. In n type of semiconductors, the energy carriers are the these electrons are negative charges. See, in the photovoltaic cell is made up of with p and n type of semiconductors. When this n type and p type of semiconductors, in p type semiconductors, there are holes are existed. In n type of semiconductors, the electrons are existed. See, the p-type semiconductors, having holes means the positive charge particles. N-type of semiconductors contains negative charged particles. These are the charge carriers here. These are the charge carriers here. The electrons are the charge carriers in the N-type of semiconductors. The holes are the charge carriers in the p-type of semiconductor. In photovoltaic cell, when these are kept together, okay, when we join together these N-type and p-type semiconductors, in between N-type and p-type semiconductors, there is a depletion layer formed or p-n junction diode. When we keep this p and n type of semiconductors side by side, then the junction point, at the junction point, there is a development of p-n junction diode or depletion layer will be formed. See, this is the n type of semiconductor. This is the p type of semiconductor. When we keep together, okay, when we keep together side by side, then what happens? There is a development of p-n junction diode or depletion layer. This white color the plus or minus, then this is the p-n junction diode or depletion layer will be formed when we keep together n-type and p-type semiconductors. Okay, this is the depletion layer. Okay, when these the plus in depletion layer, the positive and negative charge particles, okay, carrier particles, these plus and minus carrier particles will be in form of together, these are existed in together, okay, there is association between the plus and minus charge particles, okay, these are two are oppositely charged, these are associated in associated form. When the sunlight is irradiated on this photovoltaic cell, okay, when the sunlight is irradiated on this photovoltaic cell, okay, the p-n junction diode contain depletion layer, okay, this depletion layer contain this plus or minus associated form, okay, when the sunlight is fall on this depletion layer, what happens? See, the associated form of plus or minus charge particles, this will absorb the sunlight or radiation from the sunlight, this will undergo dissociation, okay, plus or minus association form will convert into the plus or minus dissociated form, okay, this after then these positive charged particles migrated towards this n-type semiconductor, okay, these positive charged particles migrated towards this n-type semiconductors, and the dissociated form of negatively charged particles migrated towards this p-type semiconductor. The positive charged carrier particles migrate towards the n-type semiconductor, and the negatively charged particles are migrate towards the p-type semiconductors, okay. Here the negative charge is developed on the n-type semiconductors, and similarly the the positive charge particles are developed, holes percentage is increased on n-type semiconductor. Similarly, the electron charge is developed at p-type semiconductors. See, there is between the potential differences existed between this n and p-type semiconductor. So the electrons flow from this side to this side to neutralize the holes, okay, the flow of electrons takes place, so energy will be generated in the photovoltaic cell. In the photovoltaic cell, first we have to join this p-type and n-type semiconductor. There is a formation of depletion layer in between the n and p-type junction, okay. After irradiation with sunlight, this association form of depletion layer will be dissociated. The positive charged particles moves towards the n-type, and the negatively charged particles moves towards the p-type, okay. There is a there is a development of potential difference between n-type and p-type semiconductors. Okay, the electrons flow takes place from p-type to n-type to neutralize the holes. So in this way, the electricity will be generated in the photovoltaic cell. See the disadvantage of the solar energies. The fish population can be impacted if fish cannot be migrate one place to another place. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.